From a recent trip to Japan, my home country, I brought back a little present. It's a traditional toy, a Japanese toy called kamifusen, which means paper balloon. And as you can see, it's a balloon made of paper, and there's a hole in there. Yeah. So the way you inflate this paper balloon when you squash it is to blow into this hole. And make it rounder. Okay. But there's another way to make it rounder. You can squash it, and then you can start tossing it around. You hit it from all sides at random. Oops. Now, when you hit something, don't you have the impression that you are denting it and therefore making it less and less round? I mean, you are denting it, right, from all sides. But look at what's happening as I toss it and hit it from all sides. I'm doing completely randomly, and you can hit it quite hard. What was shriveled to a little crumple is now getting rounder and rounder and becoming more and more spherical. And look, I ended up with a round sphere. So this is a really strange way of making something round by denting it repeatedly from all sides. How does this trick work? I think the key to this behavior, which all Japanese children know instinctively, is really in the following behavior of the balloon. When I shrivel it to a little crumple, watch what happens when I release it. You see, it starts fighting its way back. At least initially. It doesn't inflate all the way back, of course, but it has some memory and it wants to come back to where it started. It fights its way back, as I say.
Why is it even doing that? What's causing that behavior?
That's an interesting question. I have to think about this. Okay. So let's imagine the following toy model. Let's say that you have a state of this balloon, which is crumpled on both sides, on the left as well as on the right. And I'm going to strike this balloon at this moment. Path from the left, let's say. What happens, to a good approximation, I think, is that the side that you hit gets over-crumpled because I just hit it. You know, you introduce a lot of crumples. I don't know how. But the other side gets puffed out, literally, because there is this force which pushes it rightward. But you see, then something interesting happens. That fighting back effect means that the left side, which was over-crumpled, starts fighting back. So it starts expanding to roughly the degree of wrinkliness that it had in the beginning, whereas the right-hand side stays puffed out. So per this cycle, you see, what happened is that I increased the overall smoothness a little bit. The other side which got puffed out, whereas the side that I over-wrinkled fought back by itself. So if you keep hitting it from all sides, gradually you are making the thing rounder and rounder. So let's plot the evolution of the volume against time. And let's say in time, I'm hitting the balloon at various regular intervals. It doesn't have to be regular intervals. Okay, so the volume of the balloon starts like this. And as soon as I hit it, of course, instantaneously, I suddenly decrease the volume. I just shrivel it. So a hit gives you this dip. But then the thing fights back. Yeah, this is the fight back. And then the next hit will decrease the volume, and then it will fight back, and so on. And gradually, it asymptotes, or it approaches this spherical shape from below like this. So it never becomes completely spherical, but it grows like that. So I think there is a process of grow, shrink, grow, shrink, grow, shrink, zigzag, zigzag, and then goes back. And that's why you can do this strange thing of hitting it or denting it repeatedly, and yet the outcome is that it becomes rounder and rounder. Okay, this will probably take a long time. Okay. handle behave exactly the same way, whereas 45 degrees off, you get the higher pitch. It has to do with the handle, perhaps, but the symmetry breaking.